Okay, so this tutorial is going to be a little complicated, so I apologize in advance. Bear with me, but this will be a demonstration of how to use Network Analyst. And Network Analyst, in a nutshell, is basically using road networks to be able to determine more precise distance time travel buffers, or rather travel time buffers, so you can understand, like, from a certain point, how long does it take to get to other points based off of road networks speeds and parameters that you set by yourself. So for instance, let's do St. Louis. A very classic example is using the road network and metro stations to understand, like, from a metro station, how far can you walk a reasonable distance, say 20 minutes, to get to certain features to understand walkability in a site. So anyway, to get started, what we need to have is a road network, obviously. So I'm going to add a road layer for St. Louis. So I have a road map of St. Louis, and this is simply a road network that I downloaded from OpenStreetMap. So it's that OpenStreetMap data source, and these have to be single line networks. They can't be a curve network. So actually having just a road center line works best for this kind of analysis. What we need to do first is we need to clean up this data set, because this contains every single road type. It contains highways, it contains alleys, it contains paths of all sorts. But what we really want to understand is basically the areas that humans actually walk on, because humans don't walk on highways, for instance. So basically what you need to do is you need to get rid of features that don't make any sense for this particular data set. So the way you do that is you go to the attribute table here, and if I go into the look at the type column here, you see motorway, footway, tertiary, primary, all these road types here. We need to get rid of the ones that we don't care about. And so the easiest way to do that is to go to the select by attributes button there in the table. Make sure you say create a new selection in this line here. Click on type, because what we're going to do is we're going to parse through this type column here. When you have types highlighted, click get unique values. And then what we want to do is we're going to select all the types that are only of the road types that we want to keep. So double click on type, hit equals, and then let's click on the ones that we want. So for pedestrian walkways, only major roads, secondary roads are the ones you care about. So let's click on primary, then click on or, then double click type equals, let's do secondary, or type equals tertiary, or type equals residential. These road types here are basically good enough to do the analysis that we need. We can always add the other ones as well, but again, we're only focusing on the roads that really humans actually walk on. So with that selected, what we want to do is want to right click this guy, export data, select the data frame, and then just save it in a location. I'll just call this one road export walking. Do you want to add to the layer? Say yes. And then I'm going to remove the original layer because we don't need that one anymore. And as you can see, it's gotten rid of all the highways and all the other roads that we don't need. So what we want to do now is we want to take this road layer here, and what we need to do is we need to basically shatter the road network. If I click on any one of these roads, for instance, you see that the road network is continuous across the entire street, which is okay. What I actually want to do is I want to shatter the road where it intersects with other roads as well. Because in order to create a road network, it needs to know the intersection points. The easiest way to do that is to let me deselect everything. Go to the ARC catalog, go to data management, go to features, and then go to feature to line, and double click on that. Then drag in road export walking into there. And then leave this line as is, because I actually want to export this shattered road network into the geodatabase, because this only works if the road network exists within a geodatabase. And again, like I mentioned, this is a very complicated process, so just bear with me. So just click OK. Give that a second to think about it. Okay, then when it's done, you see you've added a new road network. So I'm going to turn off the previous one here. And actually, I'm just going to remove it as well because I actually don't need it anymore, so remove. So now if I select on any one of these features here, you see that it will have shattered at the road intersection point. So this is good. So now what I want to do is I want to zoom out. And then I want to do is I want to give each of these features that we've shattered a property of time. So I'm going to right click on this layer here, go to Output Attribute Table. And basically what I want to figure out is basically how long does it take to walk across that particular road. And basically what we need to do is we need to make a field in the attribute table that is a measurement of how long it takes to walk across that line. And so we need to do some math in order to figure that out. So the first thing I'm going to do is I'm going to go to the Add Field button. Make sure it's set as a double. I'm going to call this one MPH for miles per hour. Click OK. I'm going to add field again. I'm going to call this one miles and set this one as a double. Click OK. Click Add Field, and we'll call this one double as well, and then type this one as minutes. This is actually extremely important. You always, for this to work, we need this field needs to be typed out exactly as minutes, like that. If you mess this up, it might not work. So click OK. So with these three new fields, we're going to calculate the time it takes to walk across one of these polylines. So in MPH, right-click that guy, click on Field Calculator, and you're going to type in the average walking speed. And so if you Google this information, you'll find that the average walking speed for a human is generally between 3 and 4 miles per hour. So I'm just going to say 3.2 miles per hour, but you can think about what makes the most sense as this. 3.2, 3.1 is generally a good walking speed in miles per hour. So with that set, click OK. And then miles per hour should populate this column here. And then miles, right-click that guy, then click on Calculate Geometry. Just click on the yes here. Make sure the property is set as a length. Make sure this is set as the default coordinate system for whatever city we're working in. In St. Louis, it's Missouri East. And then make sure this unit is set to miles. Then click OK. Click yes. And then for minutes, go to the field calculator. And what we want to do is basically want to take the miles, the length, and divide it by the miles per hour. And that will give us the time it takes to walk across that road. Now, but this will give you in units the time in hours. And since I want it to be in minutes, you have to multiply the result of this by 60. Because there's 60 minutes per hour. So what I'll do is I'll just simply put that equation in parentheses, put a times button, and then 60 right there. So just put it in like that, and click OK. And that will give you the time in minutes. Okay, so then what we want to do is we want to create a network data set, and the only way to make that is to actually have the ARC catalog sidebar on the side open. And so the ARC catalog is this yellow button on the side, up here as well if you don't have it on the side here. And what we want to do is we want to find wherever this road network geodatabase location is. And generally, if you leave everything as a default, it should be saved in your documents, ArcGIS folder, and then there should be a folder called default. Whenever you're working in ArcMap, this almost always exists within your documents folder. And so this one is called road export walking feature T. And if I look down here, there it is, road export walking feature T. It's right here. What I need to do is I need to put that shapefile into a feature data set. So I'm going to right click on the geodatabase, go to new, then click on new feature data set. I'm going to call this one walking analysis. It doesn't matter what this is called. This can be called anything. Maybe, okay, then it's asking for for a coordinate system, so it's going to automatically say NAD 1983 Missouri East FIPS, which is correct, but always make sure that you use the coordinate system for the city that you're working in. So this is correct for St. Louis, so click on next. It's going to ask for a vertical coordinate system. So since we're not thinking vertically elevation-wise here, actually you don't need to do anything here, so just click on next. You can just click through this guy, whatever the default units are here, and click on finish. And then you see here, walking analysis, you've created basically a feature data set right here. There's nothing in it. So what you need to do is basically we need to go to this guy here that we just made, then drag that up into walking analysis. Then just drop it in there like that. So now walking analysis, we have this feature data set in there. This shapefile is what you see on the screen right now. So then click on walking analysis, right click that guy, go to new, then click on new network dataset. It's gonna ask for a name for your network dataset. It's gonna ask for version. This is all fine, doesn't matter. Click next, click next, click next. None of these things are really that important. Click next, next. This one's taking a while. Okay, and then on this page here, we need to only keep the line that says minutes. So just click on miles, click remove that, then click one way, remove that. Then click on next. Just click yes on this. If it says does not have a length cost attribute, just click yes on that. Then just click next on that. And then just click next on that. And then next on that, then finish. And then it will say a new network dataset has been created. Would you like to build it now? Click yes. Then just give that a second to do its thing. And when it's done, it says, do you want to add all features that participate in walking analysis ND to the map? You can just click yes on that. And then what you see here, if I turn off the bottom layer here, is basically what's figured out is all the intersection points, all the segments for the road network, and it's created this network data set that you can use to analyze travel time. So in order to do that, we need to right click on the, just anywhere on the toolbar here, right click on anywhere on the toolbar up here and click on Network Analyst. So that we bring up the Network Analyst toolbar. Let's just drag it down like that. And what we want to do is want to click on this drop down menu here, then click on this button called New Service Area. And this here is going to be what we're going to be able to use to figure out travel times for certain points. So let's say, for instance, you want to figure out the travel time from, say, well, this is Wash U right here. Let me add a base map real quick so that you can see. Wash U right here. So I'm going to add a point at Wash U. So click on the drawing tab right here. Up here, I'm going to add a marker. And we're just going to add a point. Let's say at Steinberg Hall, where our class is at. Click on that point, go to drawing, convert graphics to features. It's gonna say convert the point graphics, select graphics only, then click check automatically delete graphics after conversion. I'm going to name this one Steinberg. Save, okay. Do you want to add the exported data to the map as a layer? Click yes. Steinberg is there as a point. What you want to do now is you want to click on the network analyst window here. See, this is very complicated, so I apologize in advance. Like, it just seems so random how you get to all these aspects, but bear with me. The result is worth it. So again, I clicked on in the network analyst tab here, this network analyst window here, and it brings up this little sidebar on the left. In order to get Steinberg Hall to be put into this network analyst function, we want to right click on facilities, click load locations, and it's going to ask to pick points to load from that are on the map here. And so Steinberg is already there at the top of the list there, and just click on Steinberg and then click OK. And you see facilities increases in value to 1 because there's only 1 point on that guy there. Then what you want to do is you want to click on the service area line in the table of contents, right click on that, then click on properties. And what you want to do is you want to go to the analysis settings tab here. Make sure the impedance in this tab is set to minutes. And then you can set the breaks. Basically, what are the distance buffers that you want to extend from that certain point. So 5 is 5 minutes, and you can add as many as you want. So 5, 10, 15, 20, 25, 30. And I'd say 30 minutes is probably the maximum most people generally feel like walking. But they will, at least in America. I mean, I know in other countries you might be able to get away with even an hour walk, but we gotta remember that most people want to walk within 20 minutes of certain locations in order to feel more comfortable to walk there. Otherwise, they would rather just drive. And then in polygon generation, you can choose to either overlap the buffers like this. You can choose to merge the buffers like this. I think merging it looks better. It just makes the final shapefile look much cleaner. This only matters actually if you have multiple points. Since when you have one, that one actually doesn't matter, but I'll show you an example in a second. And then you can choose, does the shapefile export as rings or as disk regions like this? I'll use rings. You can choose which one you want. So click OK. And then right click on surface area here, and then you want to click on this one called solve. And then what you get basically is this analysis map here, and you can see it's pretty interesting. If I turn off the base map, well, I'll leave it on for now, but you can see that basically from this point, the inner ring here, this is your 5-minute walk. The next ring over is your 10 minute, 15 minutes, 20 minutes, 25, and 30-minute walk. And based on this, you can say, maybe it should be smaller or bigger or whatever, but as you can see, it follows the road network, so it's actually pretty intelligent about where you can walk. And because if I turn off the base map here, the road network we used didn't have any of the paths in Forest Park. That's why it doesn't show walking within Forest Park. So that's why you might want to refine the road network layer to make more sense. But in this case, let's say we only focus on walking along sidewalks and streetscapes. This would be meaningful for that. When you're happy with your final analysis, this shapefile here is located on this polygon layer in the surface area line here. You can right click on that guy, click on data, export data, maybe select data frame. It's going to ask for your location to save it. I'll just call this one time buffer Steinberg. Save, okay, yes. And now you have, if you turn off everything else, a final buffer analysis from that point of how long does it take to walk certain distances again. And if you open the attribute table here, you can see that each polygon represents a range from 0 to 5, 5 to 10, 10 to 15, 15 to 20, et cetera, minutes. And so this is a great way to do some urban design analysis in terms of travel time buffers. Okay, just for fun, I'll show you an example here of using the metro stops of St. Louis, using the exact same network analyst function that we have working right now. We have the walking analysis network data set selected here. I added a new service area like we did previously. But this time in the facilities, I'll load locations, and I will load the Metrolink stations right here, which is just a point layer. So click OK. So it adds 37 points because there are 37 stations, I guess. And then what we want to do is you want to go to the service area again, go to properties. Let's set them as overlayer merging rings and as rings. And then analysis setting, let's set 5, 10, 15, 20-minute rings. Click OK, and then right click on service area, then solve that. That might give you some weird error messages. But there you go. So now you can see basically these are the distance buffers for certain areas in from the metro stations in St. Louis. And from this, you can actually ascertain very good information about which areas are walkable and which areas are not walkable. For instance, one thing that they are considering doing in St. Louis is, if I turn on the base map real quick, if it loads up, take a second to load. Yeah, so you see between Central West End and Grand Station, there's a pretty significant gap between those two stations, and so this area in between is generally considered very hard to walk through. So they are gonna add a new metro stop at Boyle the Boyle Road Station, somewhere around here, to kind of mitigate that distance between those two. And then obviously over here, there's also a problem there as well. But that might be further down the road in the future. In any case, this is in a nutshell how I use Network Analyst to create very dynamic looking radius buffers, so you can do some really accurate and meaningful analysis of how it takes to walk certain areas. I can see in the airport, for instance, like there are no roads in the airport. You can't walk in the airport, and so this pretty intelligently figures out that, yeah, you can't really walk in there, so you only can really walk out here. But you know, even so, there's not much walking you can do in this area. So that's Network Analyst. Hopefully it's useful, and that's it.